Let's start discussing the internal rate of return, chapter 7. So you should have the slides available online in Canvas. So please look into the slides. So let's start discussing. Now, this is internal rate of return. We also call it as IRR. We already started discussing this in the class, but let me give you a recap. Now, in this chapter, our primary focus is to calculate I for a given condition, and especially the definition of internal rate of return is the interest rate at which present worth is equal to equivalent uniform annual worth, which you can see on the slide on the left, or net present worth should be zero, any one of them, for a given cash flow. So the net present worth is equal to zero, or equivalent uniform annual worth is also equal to the present worth. So either of these two conditions, we can apply either of the two conditions to calculate I. Now, for example, we have a cash flow shown in the description here. So I went over the table. So uh, how should we understand a given cash flow? So when we have a negative 1500, what it means is we have it's going out of our pocket, negative 1500. And then because we borrowed $1,500, how do we pay? We are paying, this is at the end of 0th year. At the end of first year, we're paying 1252. Second year, we're paying 1252. Third year, fourth year, and fifth year. That's what we're trying to do. So if this is what the bank asks us to pay for the next 5 years, and let's say I give you this cash flow for all of them. So this is A, pretty much this is A. And this we can say it's P. What is I for this cash flow? When we calculate, we will get 8%. But how do we calculate this? We calculate this by using this formula. Net present worth is equal to zero. That means the positives minus negatives have to be equal to zero. So we have to convert each and every number to either present worth or each and every number to annual worth, one of them. So what is a formula? So we have let's convert A to P in this case, and we have a formula. The formula to convert given A to P is P equal to A times 1 plus I to the power of n minus 1 over I times 1 plus I to the power of n. This is how we convert. So let's convert the number because we don't know I. So the meaning is let's do the net present worth. Let's calculate this. The net present worth is, already we have a negative 1500, right? Plus, because A's, all the A's are positive, what we have to say is, um, so I'm sorry, I think this is a negative 5000, right? So let me write negative 5000. I'm sorry, it's a typo. Okay, so it's a negative 5000 plus A times, which is 1252 times 1 plus I to the power n is 5 minus 1 over I times 1 plus I to the power of 5, right? So this is the net present worth, and we have to say this is equal to 0. So we have to solve this equation. So in the exam, if I were to give you, either you will see one of the options being this. So I may not ask you to solve, but you have to choose the right option in the given four options, because I converted every number to present worth analysis. Next, I can ask you to, or I can give you a formula where I convert every number to annual worth, because there is another formula where we can calculate A given P, which is basically the above formula there. So what is A given P? We can also find that. So what is A given P is pretty much P times I 1 plus I to the power of n over 1 plus I to the power of n minus 1. This is A given P. So either we can convert everything to annual worth, and we can write the same formula as, so negative 5000 times I times 1 plus I to the power of 5 over 1 plus I to the power of 5 minus 1 plus 1252 is equal to 0. Either this one, when we converted all numbers to annual worth. So you can see one of the two options. So you should be able to understand from, by looking at the formula, if the analysis is present worth or annual worth. So by solving this, we can calculate what is I. Now, depending on the intensity of the problem, I may ask you to calculate I as well. So you have to use calculator to calculate I. The calculator I use Casio FX991ES model. Some of you use TI36X Pro. So in two different calculators, the approach is slightly different, but we have an option called solve, and using that option, we should be able to solve for I. So all we have to do is type in the numbers. So I'm typing in the numbers, negative 5000 times plus, sorry, 1 2, I'm using present worth, 1252 times 1 plus I to the power of 1 plus alpha x to the power of 5 minus 1. So you also do the same thing with me. So just not only watching the video, also have this as a practice. Divided by alpha x times 1 plus I to the power of 5 So I'm using Casio, so I think we have to say alpha equal to 0, and I can say shift solve. Right, and then when I do, I get an answer x equal to or I is equal to 0.0799, which is equivalent to 0.08 or same as 8% as given in the slide. So what I've done is I pretty much inserted this equation here. I used this equation, plugged into the calculator, used an option called solve. And if you have some questions on how to use this, search some YouTube videos or use Google to see what are different approaches to solve an equation, a polynomial equation, because we have power 5 here. See, we have power 5. Even we can solve those equations in the calculator. So we can directly get an answer I, because in the exam, I don't allow you to use Excel. If we were to use Excel, the formula is pretty straightforward. All we have to use is the rate of, I think there is a format how you have to insert different numbers. So anyways, so this is how we calculate rate of return. So calculating rate of return, what does it do? Net present worth is equal to 0, exactly. Option A is correct. Uh, Present value of benefits, present value of costs, that's also true. Annual benefits is equal to annual cost, that's also true. So it's all of the above. So we have to choose an option, all of the above. So all the problems are pretty much on the same concept, on a similar idea. So I'm going to ask you, what is I? If I ask you what is I, you have to use different approaches to calculate or find out how to calculate I for given cash flow. For example, this is example 7.1. Let's look at example 7.1. So an engineer invests 5,000 at the end of every year for 40-year career. If the engineer wants 1 million in savings at retirement, what interest rate must the investment earn? So if you want 1 million, so the cash flow looks like this. We have, so engineer invests 5,000. So 5,000 is going out of the pocket for 40 years. So at the end of first year, at the end of second year, at the end of third year, at the end of fourth, and so on, up to 40. So he is $5,000 every year for a 40-year career. At the end of 40, he is getting $1 million. So for this cash flow to be true, this one here, what should I be? How will you solve the problem? Like I said, convert every number to future value or convert every number to annual worth. Do one of that, because in the slides there is net future worth. So let's do that. So net future worth or net present value, net future value has to be equal to 0. That implies, let's convert every number. So given A, how do we calculate F? There's a formula. Given A, we calculate F from the equation F is equal to A times 1 plus I to the power of n minus 1 over I. Okay, so how do we calculate given A to F using that formula? So 5000 is A in this case. So in this case, this is A, and that's negative because it is going out of his pocket. So we will write future value of 5000 annual cash flow can be written as negative 5000 times 1 plus I to the power. So at the end of first year, at the end of second, at the end of third, he is, so if for 40 years there's a cash flow, so n is 40, right, minus 1 over I, that is negative. And at the end of 40th year, he's getting $1 million. So the future worth, the future value of 1 million is basically positive 1 million. So 1 million would be is what, 1,000 and 1,000, right? So this is net future value, and that should be equal to 0. So we pretty much have to plug in the same equation to the calculator. So that's exactly I'm going to do. So you also take your calculators, do the same thing with me. Let's do it together. So we have a negative 5000 times 1 plus alpha x to the power 40 minus 1 divided with x, right, plus 1,100,000. So alpha equal to 0. Shift solve for x. So calculator takes, I think, a couple of seconds. And the answer I got here for I is 0.0700007. So it's approximately 0.07, which is 7%. That means for him, for the employee to get $1 million after at the end of 40 years, he must have a bank or a retirement account that would give him an I of 7%, which is by the way, which is possible. So choosing right retirement account, choosing how much we typically get at the end of uh, how much interest rate the retirement account earns. If we can know that, we can calculate and predict the value or the amount in the retirement account after a certain amount of time. That's how we do problems like this. So all problems we have to set up each and every problem like this. So if you have questions as we proceed with this explanation, what you can do is you can always note down the slide number that we're discussing, and you can note down the example problem number, and then you can always email me. I have this question. Can we virtually discuss this? So what I'll do is I'll set up a MS Teams virtual appointment, and then we can meet at the common time, and then we can discuss. So this during these circumstances, one way for our class to meet is virtually, either during the office hours or outside office hours. You can always email me. I'm available most of the days till 5 p.m. unless until I'm recording classes like this and uploading them to YouTube. So, and these videos will be there forever, so you can come back and uh, look into these problems if you have any questions. Okay, let's proceed for the problem. There's this firm that invests $75,000. That means $75,000 is going out of the pocket, and due to this, what's happening? Let me. $75,000 is going out of the pocket. So due to this, what's happening is this is, let's say, at the end of zero today, at the end of zeroth year. Due to this, what's resulting is $9,000 in year for next 15 years. That means if this is zero, 1, 2, 3, so on to 15, we're getting a positive cash flow of $9,000. For this to happen, what is I? How do you solve this problem? So what we have to do is we have to convert every number into common terms. Either we have to convert this to A or this to P, present worth. So let me convert this A to P. So what I will say is this equivalent, or so not equivalent, the uh, net present worth or net present value, anything is the same, that should be zero. That implies negative 15, no, sorry, 75,000 plus 9,000 is A. We want to calculate what is P given A for I and N equal to 15. That should be zero. We use this formula to calculate I, right? So we use this formula. So what is P? We just have uh, we have a formula to calculate P. So let's apply this formula, and then when we apply the formula, we can write the same equation as negative 75,000 plus 9,000 times 1 plus I to the power 15 minus 1 over I times 1 plus I to the power of 15. Please take your calculators. Solve for this equation and then tell me how much is I. Supposedly we should get 8.44%. So I didn't do the calculation myself, but that's the answer we have. So we should get 8.44%. This is a practice problem. Please do this. The same idea here. So no matter which problem we take, we have the same idea. A small restaurant costs the $350,000. That means we are spending 350,000 today. You're spending 350,000 today at the end of zeroth year. Expected profits equal to 22,000 a year, and the value becomes 400,000. So this becomes the cash flow for 6 years, 1, 2, 3, 4, 5, 6, the annual cash flow becomes 22,000, and also the value of the restaurant becomes 400,000. For this to happen, what is I? So it's up to you. You can either convert every number to present, or every number to future, or every number to annual, and do the problem. So because I've been doing present there, I can do this problem for annual. So given P, how much is A? So I'm going to use this formula here to calculate what is A when P is given. So that would be nothing but, and by the way, the 350,000 is negative. So we will get net annual worth, it has to be 0. So that implies what we will write is net annual worth. So negative 350,000, because that is P, we will convert that to A. The formula is I times 1 plus I to the power n, and the number of n's are, if you observe, 1, 2, this is 0, n is 6. So minus 1, so I times 1 plus I to the power of n over 1 plus I to the power n minus 1, right? That is negative, and we are getting a positive cash flow of 22,000, and we have a positive 22,000, and in addition to this, we have a positive 400,000, and we have to convert this future to annual. So what is, so there's a formula somewhere we have written in the slides. How do you calculate? The way we calculate is, so let me write that formula. So using that formula, what I can write is the F is given a, so what is A from this formula? Because we're writing everything in terms of annual. So that would be 400,000 times I over 1 plus I to the power n minus 1. So this formula has to be equal to 0. So because last problem I didn't solve using my calculator, you take your calculator, plug in this equation into the calculator, calculate what is I. I know it's a long equation, but let's do it together. I'm doing it on my end. 351 to 3 times I times 1 plus x to the power 6. Oh, by the way, n is 6 here. N is 6 there. divided with 1 plus x to the power 6 minus 1 plus 22,000 plus 400 1 to 3,000 times f(x) divided with 1 plus I to the power 6 minus 1. So that should be equal to 0. It takes some time. I plugged into my calculator. So let's see what value I get here. I got 0.0822. That means it's equivalent to 8.22%. Do we have that option? We have option B. That's correct. So this is how we do problems of this sort. So number one, from given cash flow, what you need to understand is from given cash flow, where in this case, this is the given cash flow. From this given cash flow, you have to identify from the description given, you should be able to draw the cash flow. Next, you should be able to apply the cash flow to either net annual worth or net present worth or net future worth. Anything, any one of them, they have to be equal to 0, and then you solve the problem. That's the approach. So how do you do this problem? Example 7.2. We do the example 7.2 using the same process. Look at the cash flow. We have negative 700. That means we're investing $700. We're investing $700, and that results in this gradient cash flow. We have to convert it into a right cash flow. So we have to invest this into cash flow here is equal to, it would be 700. It would be then it will be, so this is annual, and the gradient should start, if you see the gradient 1 2 3 4, the gradient should start from the second year, if you remember. So the gradient would start at, if 100 is subtracted, we have 75, we have 2 times 75, we have 3 times 75, right? So the gradient here, This is 75. This is 2 times 75. This one is 3 times 75. So G, the value of G is 75. Like I said, G has to start from second year. G has to start from second year. And then when we apply the formula for G, we get what is the present worth at 0th year. Remember again, G has to start from second year. And when you apply the formula of G, so what is the formula of G? The formula to calculate P given G is this. P is G times 1 plus I to the power n minus I times n minus 1 over I squared times 1 plus I to the power n. That's the formula of G. So if we apply G to be 75 and n to be 4, okay, G is 75, sorry, if G is 75, n is 4, then we get what is P at the end of, or the present value at the end of 0th year. So we get P0. So for this, you have to remember that G has to start from second and we get P0. If G starts from 3, we get P1. Always you have to do 2. So you have to know how to apply the formula when we apply the gradient. So once we know this, it's the same process again. That is net present worth has to be 0. That implies negative 700, positive find P given A. So this here is A, and A is how much is 100, right? So what is P given A? I have to look up that formula. I just wrote it somewhere here. Yeah, A times 1 plus I to the power of n minus 1. A times 1 plus I to the power of n is 4 minus 1 over I times 1 plus I to the power of 4. Am I right? It's plus I to the power of 4. That's correct. So this is for A, negative 700 plus 100. Then you have G, you apply the formula of G plus, okay, plus G times 1 plus I to the power of 4 minus I times 4 minus 1 over, this is I square. I square 1 plus I to the power of 4 is equal to 0. So when we solve for this equation, then we get what is I. And then we're supposed to get what is I. From by solving this equation. Seems that we should getting, how much should we get? think it's example 7.2. I have the example 7.2 here. So the internal rate of return for this kind of cash flow, they have done trial and error in textbook, which is, it's a long approach, but I would say it seems we got 7%. So please plug this into the calculator, see if you got 7%, approximately 7%. So that's how we do the problem. So plugging this into the calculator is not big deal, but the big deal is to come up with this equation. So if you understand this equation, then by practice you can plug this into the calculator and solve for the problem. So approach remains the same, but we apply for wide variety of problems. For example, if you see this here, example 7.3. For this cash flow, so we have present positive 300,000 at 0th year, right? So that's positive P is positive P is, P is 300,000. So identify what is what. A is negative 45,000, right? Then at the end of 5th year, and N is 5, and the future value is negative 170,000, right? So for this cash flow, what is I? So if you identify what is what parameter, we can solve for the problem. Please do this problem. We have the solution in the textbook. This is example 7.3, and we have answer here. We are supposed to get 7.5%. If we look at this example 7.4 or any other example, it's the same process again. So if you read this question, Maria borrowed $9,000 every year for 4 years. Now, one thing we have to be careful about is there is no interest charged until graduation. After graduation is when the interest is charged. So, and if you read the problem carefully in the textbook, she borrows $9,000 at the beginning of the year because she has to pay her tuition. So that is why this $9,000 that she borrowed at the end of 0th year is what she uses to pay the tuition for the first year. So this 9,000 here is the tuition amount for the second year. So on this $9,000 is the tuition amount for the 4th year. So at the end of 4th year, that means after she graduates is when the interest is applied. So for the 5th, 6th, 7th, 8th, 9th, only for these 5 years, the interest rate is applied. Now with this question, how do you calculate A? So how do we calculate A? We pretty much have to use the formula because we are borrowing $36,000, isn't it? Or Mario is borrowing $36,000, which is $9,000 every year times 4 years. It's $36,000. So this is the amount that she's borrowing. And now we have to calculate A. That means at the end of 4th year, so the cash flow, now the cash flow becomes this. At the end of 4th year, she borrowed $36,000. She borrowed, it's a positive cash flow, right? So let me erase this part here. So she borrowed $36,000 at the end of 4th year. By the end of 4th year, that's the amount that she owes to the, or that's the amount she borrowed from the bank. Now she has to repay 5th, 6th, 7th, 8th, and 9th years. This is A. First, with 5% interest rate, right? Because the rate is given as 5%. So using this, we first have to, I'm sorry, using this, we first have to calculate what is A. What's the formula? So this is 5, 6, 7, 8, 9. Or we treat this as 0, 1, 2, 3, 4, 5th year. So how do we calculate A? Given P, you have to use the formula. What is A given P? Some formula. You have to look up the textbook. Only thing is, N is 5 there, I is 5%, P is 36,000. Now I'm not going to solve, but this is how we calculate A. And once we calculate, it seems that we should get A to be 8316. So that's what is given in the textbook. Now, what is the internal rate of return for this cash flow? Now we know A, we know 9,000, 9,000 like this. So what is the internal rate of return? So what's the question? The question is for this cash flow, which looks like this 9,000, 9,000, 9,000, 9,000, 0, 1, 2, 3, 4, nothing is happening. For 5, 6, 7, 8, and 9, when it is 8316. The question is, what is I? So what will you do? You would convert everything into present or everything into annual. It depends on your discretion. So we convert everything to present. So everything to present in the sense, specifically these numbers, this is already present, right? So we convert this to present, and that's positive, and we convert this to present, so that we say net present worth is equal to 0, and then we solve for I. So now that I told you the process approach, please use this kind of approach to solve the problem. So you should practice these sort of problems, because in the exam, you have seen the exam one where I'd give you the formula, or I'd give you the final expression, which, or the final equation, which you should plug into the calculator to solve. Sometimes I may ask you to solve or just choose one of the right options of which method is correct to solve. For example, in this instance, we convert these $9,000 to present. That means because this is A, I'm going to use, I will use 9,000 as A, calculate P given A, I'll write I as I, but N will be 3, and this is positive. And negative, and negative, we have to convert these numbers. We have to convert these numbers to something that is coming like that. So that means we have to say what is F4 first of all. That means we're using this to be A. We use the formula. We use the formula P is equal to A times, not A times, A, using the formula how to calculate present when given A. When you keep I as I, N is equal to, how many are there? 1, 2, 3, 4, 5, N is equal to 5. That's it. So when we use A to be 8316, when we use A is 8316, we get the present when n equal to 5. But this present value, this p is not present at 0th year, but this is p at the end of 4th year, right? Because you're using a starting from 5, 6, 7, 8, 9. So when you apply this formula and write n is equal to 5, what you get is P4, or which is the future 4. I shouldn't write P4, but I should write F4. But we have to use the formula present. That's why I'm writing P here. The right formula to use is what is P when A is 8316, I and n equal to 5, you get P4. Or the present value at 0th year, where 0th year in this case, when you apply n equal to 5, I and A is 8316 is, you get the value at the 4th year. From this, you treat this is nothing but F4, and using F4, you have to convert it to P. So how do you convert future to present? Given F, you have to divide F4 with 1 plus I to the power n. And how many, so this is the at the end of 4th year, that means n is 4 in this case. So what is F4? F4 is nothing but P4, or what is P4 is, you have to use a formula, find P given A, which is A times 1 plus I to the power n, which is 5, minus 1 over I times 1 plus I to the power n. Then you get P4, which should be treated as a future 4, and you plug in this value here. And by the way, this is net, and that has to be equal to 0. So we have to solve for this equation. We have to solve for that equation and find what is I. So this is how we represent internal rate of return. When we calculate net present worth to be 0, the value of I for which net present worth is 0, that is the internal rate of return. The same slide, but different. Whether we are taking or whether we are investing, two different scenarios. So here, same situation. When you look at this cash flow, no matter what the problem describes, once we have this kind of cash flow, the 1000 here is P, present, and it's negative. 40 here and this 40 here, both are A, annual. 950 is the future. So if I'm asking you what is I for this case, convert everything into P or convert everything into F. It's up to you. Let's say we're converting everything into P, and then we take net present worth, right? Then what we do is we take net present worth. So net present worth should be 0. Net present worth should be 0. So we convert every number to P for this cash flow. And then we equate that to 0, solve the equation, find I. So for this problem, what do? We write -1000 because present is a -1000 and we have positive annual, so positive 40 times. What is P when given A is 1 plus I to the power of n, here n is 2 minus 1 over I times 1 plus I to the power of 2. Then we have to convert future to present. How do you convert future? And that's positive. So future is 950 over 1 plus I to the power 2 is equal to 0. Is equal to 0. Let me see if I can reduce the zoom. Yeah, this is better. So this is equal to 0. Then we can solve for I. Okay, that's how we do the problem. Then we can do some analysis problem or some comparative problems. For example, uh, we go to a furniture company or uh, uh, we go somewhere to purchase a car dealership or a furniture company. See, most of the times we're given two options. Number one, you pay in if you want to pay in full cash, we will give you discounts. When we go to car dealerships, they say we would throw you, new buyer car credit for like say $5,000 and so on. But they'll say that they'll not give any 0% interest rate. They say that we have to take the car for certain interest rate, or we can get for 0% interest rate without any of these offers. So we have to choose one or the other. For example, if you see here, a company is offering discount equal to twice the sales tax or interest-free financing for 60 months. Which one will you choose? So we have to compare. So we can use our idea and understanding for problems of this nature. So if we were to pay in full cash, we can avail the discount, which is twice the state sales tax. Assuming tax is 6%, so we get 12% off if we buy $1,000 worth furniture. So let's say we have 12% off. So 1 minus 12% of sorry, 1 minus 12% of 1 minus 12 times 1,000. This is what we need to pay if you're paying in full. Or we can have financing option, one or the other. So in this case, for example, for this case, what we have is what we have is money going out of our pocket, and that would be how much is 1 minus 12 over 100, 1 minus 0.12 times 1,000, we're getting 880. So we are paying $880. So this is 880. So then the zeroth year. Or what we can do, if we have to say equivalent, or either this or what we can say is 0 at the end of first year, not this one, at the end of first year, we have to pay some amount, second year, third year, fourth year, fifth year, and so on. not year, sorry, 6 months. This is at the end of first month, second, third, fourth, at the end of 60th month, for 0% interest financing, we have to do 1000 over 60. What is 1000 divided by 60? We have 16 points. So either we can pay $16.66 every month for 60 months, or we can pay $880. That's it. When we compare these two, when we compare this with this, what is, let's say for, let's say how do we equate these both, is what we have to see when we have to use our concepts to analyze two different cases. So because we need to compare these two situations, what we do is we convert all these 16.66, 16.66, 16.66, so on, 16.66. We convert all of this, which is nothing but A, right? We convert this A to P, and we compare this with the other one, right? We use certain interest rate, I. So what we say is 880, so what we write is we write 880 is equal to 16.67 approximately. This is A. We use the formula, given A, find P for some I and N is equal to 60. And then we solve for I. And then we get I to be 0.432%, because the way we get this is, the way we get this value is we write 880 is equal to 16.67 times, what is the formula for P given A? 1 plus I to the power N minus 1 over I times 1 plus I to the power N. That's it. So we have to solve for this equation. Then we should get I to be 0.432%. And this is monthly interest rate. How do we convert to annual interest rate? We have to use the nominal interest rate, or to convert a given interest rate to annual is we write 0.432%, which is over 100 to the power 12 minus 1. So if you remember, this is the first question I gave in the midterm 1, how to convert a monthly interest rate to annual interest rate, is we have to use this formula. And then we get 5.18%. So 5% That means if to compare $880 with a scenario where you don't have to pay interest rate, is that you get so that means for this cash flow, to compare the cash flow on the right to $880, you need to have an interest rate of 5.18%. So what we calculated is pretty much on the right hand side of the equation. What is I for right hand side of the equation? If this has to equal $880. So we are comparing this to a situation where we're getting maximum discount. So should we take discount or should we go with 0% financing? So we're comparing 0% financing, which is this. This is 0% financing. And we're comparing that with the discount. And we find out that the 0% financing is the internal rate of return is 5.18%. So we're technically, so this is the internal rate of return to match the discount, to match the discounted price. Is it worth it? Because majority of credit cards, if you look at any credit card, it is they're almost around 18%, 20%. So compared to the credit cards, this value is certainly low. So it is not a bad idea to go for 0% financing rather than availing the discount. For example, if we get this number to be around, let's say 15% or 20%, to match the value given here, that means we're getting more discount if we pay off in one payment. That means let's say this value is 700 in place of 880. That means we're getting 30% discount. What is the internal rate of return? Example, let's take the calculator and then in place of 880, write 700 and solve for that equation. So what I'll do is 700 alpha equal, let me solve that, 16.67 times 1 plus I to the power 60 minus 1 divided with x divided with 1 plus x to the power 60. Then if I say shift solve for x, so the calculator is solving. If I get 30% discount, that means we are paying $700 in place of 880. I calculated I internal rate of return to be 12.53%. So would you take discount or would you take 0% interest financing? You see, majority of credit cards are still above 12.53%. So I think even in that case as well, I think going with 0% financing is a good idea. But let's say we got 40% off when we pay in full. Maybe we get the internal rate of return almost close to 15%. Then what we can say is, I think it's a good idea to pay it off in a single payment. That means the concept we learned in this class, we can also apply this in our daily life experiences to make decisions whether to go with discount or whether to go with 0% financing if we are given two different options. So I hope you understood this, and rest of the other slides follow the same pattern. So would you go with, for example, if you're studying at UTPB for 1 year, so would you pay $180 for parking permit, which is valid for 1 year, or would you buy two parking permits for $130 each? Which option would you consider? Unless until you're graduating in December, it is always better you take parking permit for the whole year. So we can prove that. What we do is if we solve this problem in the exact process that I explained the previous problem, we end up finding that the interest rate is almost 891%. If we have to compare semester-wise parking permit to annual parking permit, this the semester-wise parking permit to match the annual permit, semester-wise parking permit has almost 891% internal rate of return interest. That's the interest we are technically paying if we pay semester-wise parking permit. Obviously, even just by looking at the numbers as well, this is 130, 130 times 2 is we're paying $260 for 1 year rather than $180. But because we are paying $130 after 5 months, things change slightly, but the solution is given here. So with this idea, with this concept, I hope you understood how to calculate internal rate of return. That's the idea of the whole chapter. Watch it for the quiz or announcements in the class, and then solve for those quizzes or the homeworks assigned. Thank you. Stay at home, be safe. Watch it for my next video. I'll post the other video soon. Thank you.